guys, we are starting the next chapter, which has to do with vectors. So, I'm going to work through most all of these to give you guys some ideas of what basic vector things are about. I will skip over some of them because this worksheet has some stuff from the next couple of lessons we don't need quite yet. But first of all, what you need to know is what a vector is. Like if you've ever seen the movie Despicable Me, whenever he says that a vector has direction, that means it's going somewhere. So here we can see that there's an arrow at the end here, and there's an arrow at the end here. That means it's going in that direction. But it also has this stuff called magnitude. Magnitude is just a fancy math word for saying that it has length. So unlike array in geometry, like if I had drawn this right here in geometry, that means it would technically go on forever. That would be array. Where this is not array. This is a vector, meaning it starts here, and we call that its initial point. And then it ends here, but it goes in that direction, and that point at the end is called the terminal point. And that's what we'll learn through the next few lessons. There are different ways to write a vector correctly. And one of the ways that we're going to write a vector correctly is in what's called component form. It's probably one of the easier ones, but it's always the one we start with. And what component form does actually is it puts it so that the initial point is like here on number 3, so that it's at the origin. Okay, so that's what it does, is it puts the initial point at the origin. So the easiest way to do that, let me erase this right here, is you just subtract your terminal minus your initial. Okay, so one more time, it's terminal minus initial. So here I see here, like here are my x coordinates, right? -3 and 8. And we can see here that 8 and -1, of course, would be right here, and that would be my terminal point, because again, that's at the end of the arrow. I would just subtract 8 minus -3, and then of course that gives me 11, right? So that's going to be my new x coordinate. When we write component form, we put them in this, like these pointy parentheses, like that. So 11 would be my new x value. And for my y value, I can see I have -1 for my terminal, 9 for my initial. So -1 minus 9 would be -10. So -10 would be the new y value. Now I know my graph obviously only, well, no, they're counting by 2s. Okay, so like if I graphed 11 and -10, that's going to put me like right, what, here, right here, 11 and -10, yeah. So that means if we were to pick up, no, I don't think it's going to let me, but if we were to pick up this vector right here and move it so that the initial point, wow, that's really straight, is on the origin, that's what it would look like, except for, prettier. So that's what component form is. Component form is just a way that we write a vector so that its initial point is on the origin and its terminal point is whatever the component form is. Okay. So in number 2, they didn't give me the picture, they just gave me the points. Alright, so all I'm going to do is subtract. Now notice, okay, so let's talk about the name. So this is obviously Ray PQ, not Ray, Vector PQ, my bad. Now just to let you know, actually in our book, a lot of times instead of the arrow, they'll use something that looks like this with just like a top arrow thing instead of the full arrow. That's also really common. So here I have vector PQ. The first point is always the initial. The second point is always the terminal. Like it's written in the order of where it starts and where it ends. So I know that this is my initial point and this is my terminal point. Okay, so whenever I go to subtract them, I would be doing -9 minus -10. What is that? -9 minus -10 is 1. And then I would do -10 minus 5, which would be -15. So the component form for number 2 would be 1 and -15. Okay, so you need to know how to take a terminal and initial point of a vector and be able to write it in component form. Okay, so that's what we did on 1 and 2. I'm not going to be doing 3 and 4 because that does involve the actual, like the direction as an angle, and we will get to that. That's just not what we're going to be doing in lesson 1. Um, but that's all it is. As you can see there in the picture, the length is 35 and the degree is 60. So, I mean, we could sketch it, but that's actually what they're going to ask us to do here on 5 and 6. It's just to understand what a sketch looks like, and that's exactly what we're going to do. We're just going to sketch it. Obviously, I'm going to have to estimate on the length, unless we had graph paper or something and we wanted to do it to scale. But like right now, we're obviously just kind of freehanding it. The big thing is just understanding it. So, so if I were to do 115 degrees, that's going to be roughly in this direction, right? And I would say, okay, this length is 26. What they're actually asking me to do in the directions to illustrate the horizontal and vertical components. That just means that, let me change to a highlighter, a skinny one here. So the vertical component would just be, or, well, I mean, go away, okay. So the horizontal and vertical components would be like if I graphed it. So like if I did actually know this point right here, my component form, it would be what is my x number, and then what is my y number. So that would be your horizontal and vertical component for the vector. And obviously, if you see what happens here is now I have a right triangle, and then I can find the magnitude. The magnitude they actually give me. That's what that is. The magnitude is 26. Okay, so the same thing for number 6. 230 degrees would be like what? Down here somewhere. And again, the length of that would be 15. By the way, see how this looks like an absolute value? Right here? That means magnitude. Okay, if you remember, the definition of absolute value is distance, right? How we talked about how it's distance from the number line. Well, here, that's the reason why they use that. It is the distance, except for from the number line, we just say it's from the origin. Excuse me, from 0 on a number line, we say it's from the origin. Okay, so again, they just want you to be able to visualize what that vector would look like. This number is how long it is, and this number is the direction that it's going in. Okay, and then we will work on, again, write it in component form eventually with the angle. We're just not there yet. That does involve a little bit of trig. So let's move on to 7 and 8. Again, we're not going to find the direction angle yet. That's for later. But we are going to find the magnitude. Okay, so all the magnitude is, if they give it to you in component form, is the Pythagorean theorem. And let me explain why. So let's do number 8 first. I'm going to do number 7 next because I kind of need to talk about the form that they put number 7 in. So for number 8, like, let's pretend I'm going to graph this so that it's pretty. Oh, wow, that's crooked. I'm sorry. Hold my iPad at an angle here. There we go. And again, I'm totally just sketching this. You don't have to sketch it to find the answer. I'm just explaining. So if I were to graph -8 and -41, that would be like crazy down here, right? That would be like way down here and whatever. And so that means this would be the point, -8, -41, meaning if I graph this, I would have to go 8 in this direction and then 41 in this direction to get there, right? The magnitude is the actual length of the vector itself. So like this right here. So notice that's just the hypotenuse of a right triangle. That's literally all the magnitude is in component form, is the Pythagorean theorem. So sometimes we do actually say that this is A and B. Like you'll see that's like quote unquote the formula for component form. So if I asked you to find the magnitude of R, it's just going to be the square root of -8 squared plus -41 squared. And I don't know what that is, but I know you guys can do the Pythagorean theorem, but that would give you the distance, right? That's all you're doing is you're finding what the hypotenuse is. All right, so 8, notice how 8 is written in that nice, beautiful component form, right? With the point in parentheses, we know that's the terminal point. If the initial point's at the origin, just like what we talked about a second ago, number 7 is not in component form. So let's talk about what that looks like. So notice this one. We have an I and a J. Okay, what those represent, this is a horizontal, I can spell, component. And the J is a vertical component. And sometimes they'll write the vector in this little algebra looking thing, because it will be, as you see, we'll see eventually later on, sometimes they're just easier to work with. Like if we start doing three-dimensional vectors. Oops, go away. But really, this is in component form. It's just 8 and 15. Okay, so they mean the same thing. If I were to graph this, this would be right 8, up 15. Okay, so it's just a different way to write a vector. Okay, so if I come up here and wrote these up here like this would be 11i plus 10, not plus, that would be a minus. That would be a minus. Sorry, y'all, it's late. Minus 10j. All right, this would be 1i minus 15j. Okay, so it's just another way of writing a vector. Okay, this is algebraic notation. So we have component form, we have algebraic notation. They mean the same thing. They just look a little different. Okay, so if I did ask you to find the magnitude for number 7, again, it's just the Pythagorean theorem. You just do the square root of 8 squared plus 15 squared, and you would work that out. So again, we will be coming back to the direction angle, just not in this initial lesson. All right, number 9 asked me to find the component form. Okay, so again, this is just like number 2. The terminal minus the initial, we can see the order that it's in, right? So that means I would do -6 minus 6, or -12. -9 minus -3 is -6. So that's component form. The magnitude would just be the square root of -12 squared plus -6 squared. And again, we'll come back to the direction angle later. If you're asked to sketch it like pretty, and then find the magnitude, and again, we'll come back to the direction angle later. 5 and no, we're going to have to count by, I'm going to count by 2s because I can't count to 12 here. So 5 would be like right here, and then 2, 4, 6, 8, 10. That would actually still put me like down here, -12. So that would be 5 and -12 if I counted by 2s. And then again, to find the magnitude, hey, I do know this one. This is the Pythagorean triple. You do the square root of 5 squared and -12 squared. That's 13. That's the Pythagorean triple. I know that one. So that would be the magnitude. Why are they these weird numbers? Number 11, let's see, -9, 2, 4, 6, 8, 9, -1 would be here. Okay, now notice here they're giving me the initial and the terminal. So -7, 2, 4, 6, 7, -2, 3 would be like right here. So this is a little tiny vector, like that's it. So, okay, so let's talk about, if they give you at the 2 points, you have an option. One, you can change it to component form, right? So it would be -7 minus -9 is what? My brain is off. -7 plus 9 is 2. 2. And then -3 minus -1, it would be what? -2. Okay, so you can do that and then do the Pythagorean theorem just like I showed you in the last few. You could also do the distance formula if you wanted to. I'll be honest with you, we all know that I have very sour feelings about the distance formula because all the distance formula is the Pythagorean theorem. But some people might like that. So just as a reminder, the distance formula is the square root of, subtract the two x values and square them. And then subtract the two y values. That's a 2. I don't know where I'm going with that. Y values and square them. It's just the Pythagorean theorem. But if that helps, like if you didn't want to change the component form, you could definitely use that to find the magnitude. So what I want you to walk away with today is know that a vector is kind of like a ray. It goes in a direction and it is measurable. Component form is in pointy parentheses. If they give you the 2 points, it's always the terminal minus the initial. In order to find the magnitude, you have to basically do the Pythagorean theorem. And then we have the algebraic notation too, which is just component form with an I and a J. Remember, horizontal is I, vertical is J. That's kind of weird. But that's it. I want you to be able to do those basic things for me